Hi, this is Professor Pate, and this example is going to be about calculating the mean, median, quartile, standard deviation, variance, coefficient of variance, and skewness. So let's take this example. During a period of 1 month, a random sample of 27 approved insurance policies were selected and listed below with the total processing times. So this is the processing times. Okay, we want to compute the mean, median, first quartile, and third quartile, the range, interquartile range, variance, standard deviation, and coefficient of variation. We want to construct a box plot, which there's a little twist to this, to determine if the data is skewed. And then what would we tell the customer who enters a bank to purchase this type of policy and asks how long the approval process takes? First thing we're going to do is run Excel's descriptive statistics function, which is going to give us the answer to a few of these. So we're going to click Data, Data Analysis, Descriptive Statistics. We're going to select our data. Let's make sure that this is unchecked and that only summary statistics is checked. And click New Worksheet since we have enough going on in this worksheet. We'll click OK. So now we were given the mean, median, standard deviation, our variance, skewness, range, and we'll go ahead and just simply fill this in. So we have 43.8. Our median is 45, which is the middle value in the ordered list of numbers. Our mean is our average value. We're looking for our range. We're able to get that from this, 76, which is simply the difference between the largest and smallest number. Let's see if we can get our standard deviation, which is 25.28. which is the average scatter around the mean, meaning how larger values fluctuate above 43.8 and how smaller values fluctuate below it. We're able to get our variance, which is 639, which is simply the standard deviation squared. So take 25.8 times 25.8 and we get our variance. Now that's what we're able to get without doing any calculations ourselves, and that's from Excel's great descriptive statistics function. Now we're going to want to calculate what the first quartile is. Okay, the first quartile means that 25% of the numbers are equal to or smaller than the first quartile number. Now to do this, we're going to put our cursor inside the blank area, click the equal sign, hit quartile. Now make sure that you just select quartile, double click it, select your data. Now that's our array. Now we need to put our quartile number, so you're going to click comma, and the quartile options are going to appear. So you'll click first quartile, double click it, close parentheses, input. So our first quartile is 18.5, meaning 25% of the values are equal to or smaller than 18.5. Now we want to take a look at our third quartile, which means that 75% of the values are smaller than or equal to the third quartile numbers. So 61.5. So we know that 75% of the values are smaller than or equal to 61. Now we want to take a look at our interquartile range, which is going to tell us what is the range for the middle 50% of the numbers. For the middle 50% of the numbers, for our interquartile range, we simply subtract our third quartile number from our first quartile. And to do that, we'll click equal sign. We'll select the third quartile number, subtract it from the first quartile number to get 43. So 43 is our interquartile range. Now what we want to do, finally, is take a look at the coefficient of variation. The coefficient of variation is what percentage is the standard deviation of the size of the mean. To do that, we're going to take the standard deviation, divide it by our mean, and multiply it by 100. Now we're going to convert this to a percentage, not to a number, not to a dollar sign, that was my mistake, but to a percentage. Because I put the dollar sign there, it ruined my calculation, so I'm going to start it over. The coefficient variation is the standard deviation divided by the mean times 100. This field now needs to be converted back to a general field since it was converted to a dollar field. So we have 58. So 58.9%. So our standard deviation is 58.9% the size of the mean. Now we want to take a look at, is our data skewed? The directions give us, direct us to construct a box plot. Now I've constructed a box plot down here using another software. The caveat is that without a lot of manipulation, Microsoft Excel does not have a standard feature for creating a box plot. So I'm going to show you a shortcut. Since we want to know, is the data skewed, we're simply going to calculate skewness. Skewness measures the extent to which a data set is not symmetric. So if it's positive, it's right skewed. If it's negative, it's left skewed. So we're going to put our cursor here, click equal sign, skew, and simply add in our data set and close it. So our skewness is 0.517. And for the purpose of this problem, that's a positive number, meaning our data is right skewed. Since it's right skewed, we know that most of the values are going to fall in the lower portion of this distribution, meaning that most policy processing times are not going to take longer than the mean time.